Hey y'all, welcome back. Good to see you again. Thanks for joining me on the channel. Today on my bench I have something that's a little different from what I usually work on. This is a realistic STA 780. It's a digital synthesized AM/FM stereo receiver. This was rescued from the dumpster. It wasn't actually the dumpster, it was the recycling bin. It was going in for recycling and I saw it at the bottom, and I knew it was something. I didn't know it was a realistic, but I grabbed it and pulled it out and brought it home. It's complete except it's missing one knob from the treble slider here, and it is pretty dirty. It's filthy. It's got that nicotine glaze on it, and it's got quite this stink of smoke. But other than that, it looks pretty good. It's not really damaged anywhere. It did have, I think it was from probably throwing in the bin, the bottom corners were bent in. But I have since bent those out a little bit, and it seems to be a lot better. You can't even really notice it anymore. But yeah, it's an interesting little receiver. It's digital, and we're going to see what we can do with this. So let's have a good look at it. Okay, so let's have a look at the front here for the features. Chunk power button, 2 speaker switches, phono, headphone jack, bass treble sliders. This one's broken off, and I think this one's broken too. It doesn't feel right at all. It's just messed up. It's got this huge display for, well, we'll get to that. Tape monitor, AM, FM, phono, CD auxiliary, TV auxiliary. These are soft buttons, so they're doing some switching inside using some chips and tuning up and down. There's a nasty scratch on this. And then tuning presets, memory, search button, FM mute. It's got a detented volume knob. This knob has quite a bit of damage to it, like it got hit with something. I might have to buff that out a bit. And then the coaxial balance control is hidden behind there. Subfilter for phono, mono switch, and loudness switch. So let's turn this on, and you should be able to see the display comes up. It's side lit, and it's got like a little map of what's going on here. The selector, AM, FM. The little LED corresponds to which mode you're in. Memory. Let's see here. Go FM. You can select whichever memory you want. Search button. Everything's lit up with LEDs, which is okay, I guess. Vacuum fluorescent display showing your station and your scan. Signal strength meter on this side, FM stereo light. There's some more lights up here. The tape monitor light, loudness light, subfilter light. So everything's got its own LED to display on this little map, except for the speakers. The speakers don't have any indication on what's going on, but looks like everything's working so far. The tuner is scanning through, and it's picking up some signals. It's not locking on any of them because I don't have anything connected for an antenna, but hopefully it's all working. Let's have a look at the back. So the back has inputs for your antennas. It's got this capacitive clamp thing that's on the power cord that kind of works like an antenna. It picks up the FM signals anyway. Coaxial input for FM. It's got phono, CD auxiliary, TV auxiliary in one tape loop, 2 speaker outputs, 1 courtesy outlet, and 1 fuse. And it's got a bar antenna for the AM. Looks like it's intact. It's not broken, which is good. So let's have a look inside. Alright, so a power transformer is mounted on the side. There's also another little transformer here. I don't think this has a remote. I think this little transformer is to keep the memory presets alive. So when you plug it in, even though it's switched off, I think this is supplying power for that memory backup. You think they could have just put a battery in there or something? It would have been a little simpler and less wasteful in the power. It's got discrete power amplifier. I don't know, you can't see the transistors, but they're under there. And there's 4 emitter resistors, so it's all discrete, which is nice. I like that. A little bit of power supply section here. This is all tuner on this side, and not much to say. It's a nice, pretty color on the wiring looms. Power switch up top here, and a fuse, another fuse. This is the back side of the front panel. You got the in the center there. You can see the volume and balance pot. And go over here. We got a display board, which is covered over with a microprocessor board. So we got a lot going on there. And that green board underneath, that's mostly all LEDs and display. Fairly basic unit. It's nicely optioned out. So let's hook it up and see what it does. Alright, so we got the speakers connected. Let's try this out. Turn on the speakers. We're on FM right now. Let's try search. It's having a hard time pulling stations in. Let's turn it. It's pretty weak at picking up stations. Let's continue searching here. It's not locking in on stations even when I got 5 bars. Okay, let's we got no stereo. So maybe the tuner's a little messed up on this thing. I got full 5 bars. It won't lock when it's scanning, and we don't have stereo signal, stereo beacon, so maybe there's something messed up in the tuner. So AM.
This is like, you know, you're in that area, you have to.
AM seems to be.
We design new ways of delivering by controlling their release in innovative ways.
AM's working, it's locking in on stations, so I'm assuming that's all working. I just heard a big pop come out of the left speaker, and I have a feeling I know what that could be.
The body, and again, we've been focused on the central nervous system. So
when I touch the base, this pod is messed up. It's making connection when I touch it.
we've been looking at transplanting those cells back into the eye. Now, what most people don't tell you is that most of the cells we transplant, most of those cells die.
Okay, so we're going to need to fix this and this. But aside from that, everything seems working except for the FM. And actually, it's fairly good shape. It's not badly abused or anything. It's just dirty. So it'll make a nice receiver once it's cleaned up. I think it's going to be mostly cleaning, but we'll have to address these tone controls, and we'll have to address the FM tuner. Other than that, it seems good.
You'll know that if you just throw.
I mean, I think we use it as a tool for sure. You mean, these kids are in various different stages of their development.
Let's try the auxiliary input. I'll try a song here. It's working.
There's, you know, there's
A lot of bleed through on the circuitry. You can hear the signal. Tape monitor. Sounds good. Okay, so let's get started. Okay, so here's a quick look at the bottom. You can see the bottom panel's all bent. You can see this, it's all looks like somebody either put too much weight on it or dropped it, so I'll have to straighten this out. It's fairly thin metal compared to other receivers I've looked at. But take the bottom off, you got full access to the main PCB board. Everything's accessible, easy service, so that's good. What I'm working on right now, I'm just taking the front panel off. And I'm going to pull this panel off so I can find out what's going on with those two tone controls. Okay. Got a ground wire here. Everything looks good. Yeah. This one pot. Got the black cloth on there to keep the dust out. I'm going to have to replace those pots. Let's see, we got 4 lamps here. Let's see how many of these are burned out. Okay, yeah, they're all 4 of them are working. That's good. Alright, so here's the base treble controls removed. These are actually sockets that the wires slip into, but I was tugging on them, I couldn't get them to let free, so I just desoldered them. I didn't want to bust anything, but I think these come right out if you pull on them hard enough. But look at our pots. This one's got the control arm snapped off. It seems to be intact though. This one here is really messed up. This is the base. And they're both 100K pots times 2. So I'm going to look and see if I can buy replacements. I'm just going to replace these 2 with new ones and go that route. I don't think I can do anything more for these pots. If I had similar pots, a similar style, I could disassemble them and scavenge parts off of one to put on the other. Like this one, I think I could probably fit back together and make it work. But I'd rather just replace it. So I'm going to get on the interwebs and start looking for new pots. Alright, looks like I'm in luck. I was just on AliExpress and was doing some searching and up they came. They're called 45 millimeter slide potentiometers. And these ones measure out at 45 millimeters. And they're the same dimensions as the ones they have on the page. So they're pretty easy to find. They're not bad. They're $2.50 each. So I got 4 of them. And they should be here in a couple weeks. So I'll put this aside and we'll work on the other parts of the stereo until this comes. Alright, so I'm going through and testing capacitors and I'm finding a lot of high ESR ones, especially in the power amplifier. Around this little regulator here, there's a lot of cooked capacitors. And I'm also finding high ESR capacitors in the tuner as well. So I'm kind of thinking this might see a full recap. There's a lot of capacitors in here. Like there's about 20 or 30 just tucked in behind here on this, what looks like to be the tone board, or tone portion of the board. Yeah, so it looks like it might get a full recap. I'm gonna pull a few out and test them on my other tester. This little capacitor checker, where is it? Okay, this is good for spot checking, but it's not a definitive meter for condemning a capacitor. I like to pull a capacitor out and test it on my LCR bridge, and that one gives me an accurate representation of what the capacitor is all about. So, for example, if I check one of these capacitors, let's pull one out right now. Let's see here. Let's pull one out right now, and we'll check it on both machines, and we'll see what the difference is. If I can find the pins, I think this is it here. Okay, so this one's a 330 at 25 volts. My little checker, I can probably see it. Let's see what it says. 0.16, 0.14. Probably as it cools down, it'll go a little higher. This one is probably borderline good. Let's check it on the other machine. I know you can't see it for now, but you're gonna have to trust me. I won't lie to you. Okay. So it has a capacitance of 313.9 microfarads, 314, let's say. And it's got an ESR of 367 milliohms, and this one said 140 milliohms. So there's a big difference between the two meters. This one's got a higher ESR on the real capacitor tester, which puts it out of spec. It shouldn't be that high, not for, let's see here, 25 volts. It should be less than 200 milliohms, not 300 and some. So I think a lot of these capacitors are going to be condemned. We can try another one here, I can show you. Since we got the tools out, let's do it. Okay, this one here concerns me because it was cooked. This one's cooked. Alright, so this one here is a 22 microfarad at 50 volt. Delcon brand. It's kind of a garbage brand. 22 microfarad at 50 volts. So according to this, we should have an ESR of somewhere between 1.5, somewhere around 1.5 ohms. Let's see what we got here. Let's connect this up and try it out. We got 26 ohms. Definitely a cooked capacitor there. Let's take it and try it on the other machine. And we are measuring 19.2 microfarads, and ESR is up at 37 ohms and climbing. As it cools down, it gets higher. It's down at 38. Now it's at 39. So it's definitely cooked, and it's a weak capacitor. Even though the unit's still working, I'm going to replace them. So here's a look at the main filter caps. These are 6800 at 50 volts, and that's what it's reading, 5200, 66 microfarads. The ESR is good, but they're down on capacitance, 5200. Let's try this one here. I think it's about the same. And this one's at 53, marginally better. I'm going to replace these. I'm going to find a suitable replacement and put the new ones in. Hey, have a look at this. This is the pot for the base control. And I was desoldering the pins on the back. this blob here, this solder blob, that's from the factory. This has never been a part before. This is from the factory. So what we got here is we got a potentiometer, 2 channels. This is the center wiper for each channel. Let's say this is left and right, for example. And this is the center wiper. These are the 2 extremes of the potentiometer. So these 2 outsides were shorted together, and I don't think this potentiometer, or the base potentiometer, was working on the one channel. That's odd. It's funny that got through like that, but that's going to be fixed. Alright, so it's a few days later. I've taken a break. I was working on other stuff, but I spent probably a full day just replacing capacitors in this thing. And you can see I replaced everything that I could. Everything's been replaced. Now, I found the problem with the capacitors isn't that there was a lot of dead capacitors. It was that there was a lot of failing capacitors. I replaced 75 capacitors. 15 I replaced with film, and the remaining 60 I put brand new electrolytics. They all had fairly good capacitance rating, but they all had high ESR. What I mean by high ESR is like 2 or 3 times the recommended. So I can start putting this thing back together. I still haven't received my potentiometers in the mail. I'm still waiting on that, but looks like I can start putting things back together again, and everything else is falling right into place. Nothing else to talk about at the moment. Alright, so my new potentiometers came in yesterday. These are the ones I purchased on AliExpress, and they should be direct drop-in replacements. Let's have a look. Came in a lot of 4. They are look like pretty quality units. Okay, let's get an old one here. Where are they? So, what do we have? We have pin for pin. It should be identical. And it is, except it has this grounding pin here to ground the potentiometer, and this doesn't have any grounding, so I'm going to have to cut those pins off. I'm wondering, should I connect those to ground? No, I'm just going to leave them. Actually, I just bend them down. There we go, bend them down and they're out of the way. Yeah, looks good. Looks nice. They're identical in every way, even a little better quality, I think. This doesn't have the center detent like the originals. The originals ones had center detent here. But these are quite a bit stiffer, the old ones, and these ones are actually pretty smooth. So let's get them installed. Yeah, I'm happy with the qualities, and I paid what, $10 delivered for these 4. I got 2 spares now, and we're going to install 2 of these. Perfect fit. Now, I did damage the PCB board here a bit when I was desoldering it. It's not a big deal. I can fix that up. And here as well, I can run a jumper. But yeah, that's going to do the business. That's nice. Feels good. So I'm pretty much done everything else. I have replaced, I think I counted like 75 capacitors. I went through and did a full recap, with the exception of a couple of capacitors I pulled out and they tested perfect. They were the non-polarized caps that were in some of the circuits, and I left them alone. And I think there's one in the tuner, maybe one in the preamp. So they tested perfect. I put them back in, and I typically don't store stock non-polarized caps. Okay, I just need to fix up this connection here on the back end, and then we can reinstall this. Alrighty, I think we're ready to do our initial power on test. I got everything reassembled. I think we're ready. So let's turn it on. I'm going to plug it in first. Here we go. Turn it on. You can see smoke or pop. Nope. Let's turn the lights off. So what are we on here? We're on AM. Oh, let's turn the speakers on. What the hell's going on with this thing?
And kind of off the cuff here, when we're talking about estate planning,
I don't know what's with this signal meter.
Is life insurance part of an estate plan?
Base works.
Certainly, Wayne. It's one of the other tools in our toolbox. And
Treble's working. How do we initiate scan? Here we go. Still got problems with the tuner. Okay, let's get rid of this. It's really quiet, the FM.
And with one of the only spots in the city that has hot,
Still no stereo. And we got a problem with the power meter now, or the signal meter.
This luxurious, and then wait till like 2024 to get delivery.
FM is quiet. Like that's a local station that should be tuned in right now. So we still got problems. Tape monitor.
Rated well, so you know how to do that.
AM's working well. FM is not. Kind of a thump between switching inputs. Can you hear that? Could be normal. Alright, let's figure out what's going on with FM here. Alright, I'm just trying to poke through this and troubleshoot some of the problems I got. Signal meter. I disconnected all the wires. Here's a connector for it. And I connect up the power and the ground. And the signal meter comes on. So whatever reason that signal meter is displaying a full signal, something going on with the board, I'm going to have to disassemble this all again and take this board out. This board is buried underneath the display. Well, it's part of the display. I did have it out and I did look it over and it looked all fine to me, but maybe I screwed something up when I put it back together. Okay, this thing is totally weird. I'm getting confusing things going on here. Let's see if I can get a meter happening here for you. So what I did is I disconnected it from the rest of the tuning circuits, and the bars still stayed up high. And I'm figuring, what's going on here? So I even went as far as to ground the input pin of this little chip here, back here, and I still had 5 bars. But I'm monitoring the voltage of the input pin, and it's slowly dropping. I'm down to 125 millivolts now. And it actually, oh, see there, I just lost another LED. So the voltage was up to around 300 and some millivolts, and I had 5 bars. And now it's slowly dropping. Now I lost 2 bars, and I got 3 left. Some kind of phantom voltage on this chip that is keeping it lit up. Now there's a little simple circuit here. If I go, oh, where did I put my papers? I downloaded a data sheet for this chip. Pin 8 is our input for the signal. There's a couple little support components. There is a capacitor, electrolytic capacitor, and a 35K, 33K resistor to ground. And that goes to pin 7. That's some kind of internal compensation. Pin 8 is our input. That's the one with the floating phantom. Unless I'm getting a phantom voltage through this resistor here. There's a 220K resistor that's supposed to be tied to ground. And if I measure it, there it is, 220K. Okay, first of all, let's measure this side. There's my phantom voltage, 122 millivolts. It's holding steady. And here's the other side, which is supposed to be ground. It's at 5 millivolts. What is going on with this chip? Do I have a bad cap? I didn't change this capacitor. It is a 10 microfarad at 16 volt. It's like a little tiny micro cap. I don't suspect that's the problem though. What do I got for voltage on one side here? Negative side I got 5 millivolts, which is my ground potential. The other side I got 1.15 volts. And dropping. I'm not exactly sure what that's all about. Now it says in the spec sheet 85 millivolts should light up the middle LED, the third, and I'm still at about 116. Seems like when I touch the probe it's picking up probably stray signals. I'm going to change this cap, even though I didn't change it last time. I don't know why. There's really nothing to go wrong with this circuit. Nothing's overheating. Or wait a sec, this is hot. This chip is really warm. Maybe that chip went bad. Why would the chip go bad? That's really funny. Let me try if I have that chip. I'll see if I have one. I doubt it. Okay, I'm just monkeying around with a little bit of cold spray, and look what happens here. When I spray this chip, I got all 5 LEDs on right now. Spray it. Now it's not going to do it for me. See how that chip is heating up. First time I did it, all the LEDs went off, and then they slowly came back on again, one at a time, as the chip warmed back up. I don't think it's this capacitor or that capacitor or those resistors. I think it's the chip itself. There we go. See, now it's cold, and that when it warms back up, so I'm pretty sure that chip is defective. I don't understand how it would go defective. I didn't do anything to it. So let's see if I can find one of those. Okay, so what I did is I removed that old cap. It's right here. It's a tiny little cap, and it measures, it's a 10 microfarad at 16 volts. It measures 8.3 microfarad, 22.5 ohms ESR. Let's see what else it has. Dissipation factor 0.142, Q factor 6.9. I think this capacitor is done. Even though it doesn't really measure that bad. It didn't measure bad ESR in circuit. It's still measuring bad ESR here. But anyways, I replaced it, and now my meter's working. So that was really odd. So as you can see, as I tune through the band, it's got my working signals again. And this chip is not getting hot anymore. That was really odd. I didn't think a capacitor would do that. But, and the one capacitor I tested in circuit and it was fine, so I left it alone. All these capacitors in there were changed out. Every single one of them, except for I think 3 non-polarized ones. Alright, just going to go over some schematics here just to let you know what I'm finding on this receiver. I got a few problems on my hands here. I don't know if they're related or not. One problem I'm kind of scratching my head over is this signal strength meter. It's five LEDs. It's run by this chip, this LB1443. Now I'm getting a phantom voltage on this line here, M3C3. This is the signal strength line that, you know, if it's a voltage on here, then the meter responds. And when I first turn on the receiver, I'm getting about half a volt on this line. It's a phantom voltage, and the reason I call it phantom voltage I'll explain in a minute. And then as time goes on, this slowly drops down to, you know, 300 millivolts, 150 millivolts or whatever. And as the voltage drops on this line, then the LEDs start turning off to signify that this chip is working. And I went through the data sheet for this chip, and it said for LED number 3 to turn on, which is your middle LED, you need about 85 millivolts on the signal line. So what I did is I changed this capacitor, this C327. It is a 10 microfarad at 16 volts. It's not marked here. Oh yeah, there it is, 10 at 16. And I pulled it out. It tested fine. And when I put a new one in, this seemed to behave a little better. Now I'm not sure what I did here made any difference, because if this capacitor is leaking, it's really irrelevant because there's a 33K resistor in parallel with it. So of course there's going to be a leakage. But it didn't seem to fix the problem. This chip was also getting warm, and when I sprayed it with cold, it seemed to start behaving. But I'm getting a phantom voltage on here. This is supposed to be at 0 volts, and I was getting about half a volt when I first turned it on. There's a 220K resistor and a capacitor here. That shouldn't be any problem. But if I follow the line back to the other circuits, let's have a look here. Okay, if I follow the line back to the AM chip, the LA1245 is your AM chip. there is a blocking diode here, and then a potentiometer, and then another potentiometer, and this line comes out of the chip pin 16. I don't know what that is. I haven't looked it up yet. But I measured voltages on both sides of this chip. On this side I have the phantom voltage. On this side I have 0. So I know this is not feeding a phantom voltage in. So that's good. Let's go look at the other chip. If I follow the line, okay, if I follow the line back, it comes to this diode here, D102. It's another blocking diode. If I measure on the bottom of this diode, I get the phantom voltage. If I measure on top, I get 0, or close to it, like maybe 5 millivolts, 4 millivolts, something like that. So, and this is the FM chip, the intermediate frequency. A lot of this FM is handled in this LA1232. So I'm not getting the voltage from either the AM or the FM section that I can see, because there's only one connection here and there's only one connection here. I'm beginning to think this chip is bad. I had it apart yesterday. I looked at the board. I can't see why any phantom currents would be leaking onto this line. There's no circuit glue in the way. There's really nothing that's causing that that line on that chip to go high, other than internally, I'm believing. So I think it's bad. This chip is bad. So I might have to seek one out and replace it. Now, if I follow the traces, this line here is supplying power to this chip, and it's fed through a 100 ohm resistor. And then it has a 220 microfarad cap to keep it clean, and then it's fed into pin 1. Now I can measure the voltage across this 100 ohm resistor, and I came back with 2.4 volts or something. No, 2.8 volts, right? Yeah, 2.8 volts across this resistor. So that equates to 28 milliamps drawn by this chip. Now if I go to the data sheet for this chip, it has absolute maximum rating 40 milliamps. But if I go down, it has a typical rating, ICC, typical is 24, max is 32, and I'm reading 28. So it's right in between the typical and the maximum. It's a little bit high, but that's okay. I think it's still good. The other chip, the LA1232, has a 100 ohm resistor right here, R111, and this is the power feed, the same B plus power feed, and it goes into here, pin 11. So if I measure the voltage drop across this 100 ohm resistor, I'm getting 2.13 volts, which equates out to about 21 milliamps. So I think this one is okay too. If we look at the data sheet for the LA1232, so here again, if we look at the characteristics, we have quiescent current. ICC is typically 22 milliamps to 30 milliamps, and we're getting 21.3, so we're just a shade below typical. So I think that chip is okay. It's running correctly. It's not overheating. And same thing if I go to the AM chip, the LA1245. This is the power input here. Comes in, goes through 100 ohm resistor, R210, and then it goes straight into pin 14. There's a 100 microfarad decoupling cap here. So this is our power feed. And I measured across this resistor, I measured, what did it come out to? 2.2 volts, which equates to 22 milliamps. So this chip is operating fine as well. So I don't think I have a problem with any of these chips within the tuner circuit. So the problem I'm having with this tuner is I got low FM output, like the audio output is quite low compared to the AM. The AM sounds fine. You get bright, clear AM audio coming out of this tuner. When I switch it to FM, it goes quiet. Now, I'm beginning to think it might be just an alignment problem. Okay, here's a block diagram and the internals of the LA3390. This is pin 11 to 20. So in pin 11 I have a 19 kilohertz output. I have a ground at pin 12, stereo indicator at pin 13, capacitor, tuned circuit here on pin 16, another capacitor network on 16 and 17, or 17 and 18, another capacitor at 1920. So if I go down to the other side of the chip and start looking at what's going on here, pin 1's my VCC, and pin 2 I have this here, AM input. So the AM input is fed from the AM tuner and fed into this line, and it's switched internally between the AM and the FM depending on the mode I'm in. But I'm getting a good signal through here, and it's coming out just fine on the stereo outputs, the AM signal. Its problem is when I switch it to the FM, I'm not getting a good clean or good high level output. FM input comes in through here, through pin 3. It looks like it goes through 2 buffers, and then it goes into this switch, and then depending on the mode, it goes down and it comes out the post amp 9 and 10. So this is your left channel, your right channel output. So basically what 3390 is just a demodulator chip. Let's see, you can't really, it's all written in Japanese. It doesn't tell you what it is. Phase lock loop. I can't read any Japanese. Can you guys tell me what that says? The FM input on pin 3, let's look where that comes from. Let's go back to our main schematic. Pin 3 is here, and it goes through a 10 microfarad blocking non-polarized. That's probably a capacitor I never changed, a 5.6K resistor, and then it's fed from pin 6 on the LA1232. So this is our FM output. Pin 6 is an audio output. Let's have a look at that on the data sheet. So the block diagram, we got input, this is IF amplifier and limiter, you got first, second, third, fourth, fifth, and sixth. Goes through a quadrature detector, and then it goes down into the audio frequency amp and out pin 6. So this is our audio signal here coming out of this chip on pin 6. I happen to think I'm going to scope this pin. Let's have a look. What does it say for pin 6? So it has a rating here, demodulation output, V out, V in with 100 dB, 400 hertz, 100% modulation. We should be getting 240, well, around 330 volts RMS. That should be our output on that pin, I think. But we could try it, we could feed a signal in and see what we get on the output. If it's low, then we know there's something wrong there. Yeah, and this confirms it here. It features a high demodulation output of 330 volts RMS, typical. So that's what I'm going to shoot for. I'm going to measure this and see if we have 330 millivolts typically at the output with a normal input signal. And if it's low, we'll have to start investigating why it's low. Is there something going on within the circuit surrounding support circuitry for this chip, or is there something other else wrong? I don't expect the chip is bad. I think the chip is doing exactly what it's supposed to do, but we'll have to figure this out. Okay, so what you're looking at there is the output of pin 6 of the IC, the LA1232. This is the IF chip, FM IF chip, and that's supposed to be the audio output. And to me that looks suspicious. That's we got a signal that is off balance. Now I got my scope set to AC, so if I shut it off, let's see, hit it 10 times, you can see it's, where is my balance here? Okay, so we got it set 0 to the line, and we have a lot of noise on the negative portion. So I'm going to start feeding it a signal. I got it hooked up to a signal generator, 99 megahertz, and I got 1 microvolt right now. Let's turn it up. 2, 3. Starting to get our signal through. Let's keep going. 25, 35, 45. Okay, so I'm feeding a 45 microvolt signal, and all we're getting back is 100 millivolts on this is 100 millivolts of division, and we're only getting 100 millivolts out of pin 6. And the data sheet said it was something like 350, I think, or 335, something like that. So we're down. But I think there's a reason for it. If I turn this down again, looks like the discriminator is not balanced properly. Now I was fiddling around with some of the pots here, so maybe that is part of the problem. So let me try tweaking. There's 2 pots in the circuit, trim pots. One of them is, I can barely read this schematic, so tiny. One is VR103, and the other one I can't read. VR102, VR101, VR103. Let's try 103. Does absolutely nothing. Okay, here's our look again at the output of IC 101, which is the LA1232. And I have, shut this off. The signal generator is creating a 1000 hertz tone. We're modulating 99.0 megahertz. I got a nice strong signal. I got 5 bars on the output of the tuning meter, and I'm only getting about 100 millivolts signal. It should be 300 and something. Another problem. Let me turn this up. Modulation, I'm going to turn it up to 19 kilohertz. Get 12, 13, 14, 15, 16, 17, 18, 19. I have no stereo beacon light whatsoever. I don't know what's going on with that thing. What do I have for a signal here? 20 millivolts. Looks like I got about 75 millivolts. Yeah, about 75 millivolts now. And it should be up around over 300. No stereo beacon light. I did set the internal oscillator to 19 kilohertz, but it does not lock. I'm beginning to wonder if that chip is bad, that 3390. If I have another one, I could pop it in and find out. This is starting to really annoy me, and I'm ready to at the point where I'm going to give up here because it's starting to irritate the hell out of me. Okay, this is where I'm at right now. I'm at a loss with this tuner. What I'm going to do is I'm going to just leave this tuner as it is because, for one thing, I got customer repairs sitting in the back waiting, and this is consuming a lot of my time and energy and actually patience. And I'm not giving up on it, but I'm going to just put this aside for now because I'm getting pretty frustrated. Let me tell you where we're at now. Actually, you know, I'm going to put the word out to my viewers. Maybe you can tell me what's going on with this thing. The AM tuner is working perfect. The tuner front end seems to be working perfect. It seems to be pulling in channels. Might not have the greatest sensitivity, but it is working. And I'm not thinking the problem's here. But this chip here, this LA3390, this one seems to be where all the issues are. That chip is the stereo demultiplexer, and the problem this thing has is it has low audio output, and I determined it's because we have low audio on this chip here, which is the IF strip, and we have no stereo beacon. We can't tune in a stereo signal. It doesn't lock, and we're not picking up anything stereo. and normally I would go through an alignment and just realign it to see if that would bring it back, but unfortunately I don't have any service manual for this. All I got is a schematic. So I'm going to put it out to you guys. What do you think it is? It's been recapped. I replaced a lot of these electrolytics with film caps, these 1 microfarads. I don't think that's a problem. It's got all brand new electrolytics except for this one, which is non-polarized, and this one, which I pulled out probably 3 times now and tested. It's a 2.2 microfarad. It's an ELNA cap, and it tests perfect, so I'll keep putting it back in. I'm beginning to think I might have a bad ceramic capacitor somewhere here. I don't know, or film cap. I've gone through and I've tweaked these 2 coils. These coils are for the FM, I don't know what they're called exactly, discriminator maybe? I'm not sure. But they have some effect on the signal, but they don't seem to bring in the FM stereo. I've set the 19 kilohertz to 19 kilohertz, the oscillator. I've set it to 19 kilohertz. I've tweaked this one. This one is irrelevant. What else is going on here? And that's all. Maybe somebody can tell me something I'm missing here, something obvious. But I'm going to leave this alone, and we're going to move on to other parts of this. We're going to do the power amplifier testing, because I'm curious as to how the power amplifier works now after I've recapped it. And I want to get this off my bench because I've got other projects on the wait. So, all right, let's focus our attention on the audio amplifier in this thing. I'm kind of curious as to how it's going to perform now that I recapped it. I haven't had much experience with realistic equipment, so I'm kind of interested in how this thing does. So let's have a look. I got it on AM right now. It's passing a signal, I thought. It is.
60s, into 60s, but Wayne got it.
And we still have a problem with our tuning indicator, because if I go to FM, oh, now it's starting to behave. But when you first turn the appliance on, or the stereo on, it has 5 bars, and then it slowly creeps down, or settles, let's say. For those taking notes, this thing sitting at idle consumes 32 watts out of the outlet. This is barely warm on the heatsink here, so we got probably a fairly good idle current. Turn this on. We have fed into the auxiliary a 1000 hertz tone. There it is, and you can see the potentiometers are clean, balance, volume is clean, switches are good. There really isn't any switches. These are all electronic, these function switches. Speaker switches are good. Everything's good. So let's shut the speakers off, turn on our electronic load, our load bank, and we can start turning this up until we get a signal. Might have to increase the sensitivity here a bit. Let's try this. Keep going up till we get clipping. There's our clipping. Back it off 1 notch on the volume pot. And we are getting 22.58 volts RMS on the output, which is pretty good. I wasn't expecting it to be that high. Let's let this cook for a while, see how it does. I'm really curious to see how this sounds when I put it on my desk and I give it some critical listening. I have a feeling this one's going to sound pretty good. Another thing to note on this receiver, there is no bias adjustment for the audio amplifier. It is all preset and unadjustable, so just go with that, I guess. You can see a little bit of 60 hertz flutter there when I turn up the volume knob one notch. Turn it back down, it goes back normal. I did upgrade these output capacitors to 8200 from, I think it was I can't even remember now what they were, 68 or 5600, but now they're 82. We let this go for a while. Starting to get warm. Okay, we're probably 4 minutes into this test, and it's getting quite warm. I don't want to cook my amplifier here, so I'm going to shut this. This is quite warm too. I have my heat sink. It's probably a lot of heat. Let's shut this down. I think I've seen enough. And let's set up for a frequency response test on a sweep. Alright, so I'm set up now for doing a sweep. So I'll turn the sweep generator on. I have the output of the amplifier at around 2 watts per channel. So let's turn this on and have it run it. And we'll see. This is a sweep from 10 hertz to 50 kilohertz. And just want to check how flat the response is, and my tone controls are set flat. If I turn up the tone, the treble, you can see how it emphasizes the high frequencies, but we're going to keep that centered. And we're going to notice that it rolls off right around 20 kilohertz, starts rolling off 36, 41, 50. You get a bit of a drop on the high ends. As you can see, the low frequencies are pretty good up till about 15 kilohertz, which is not bad. I've seen better and I've seen worse, but we'll just leave it at that for now. So that concludes everything I want to do with this amplifier. Other than fix the tuner, I want to revisit this tuner business. So like I said, if you have comments, leave them in. If you have any ideas, leave them in the comments, and we'll get back to I'll revisit this back in the winter when I have more time. My goal is to get this 100% functioning so that I can sell it to a new owner. I'm not going to make a lot of money off of it, but I want to make sure that the new owner has a properly working piece of stereo gear. So that's it for this one. Thanks for watching, and stay tuned for the next one. Thanks.